Now, thank you for asking. We are recording now. For example, base maintenance services. It's one of our job. We check all of the components of the planes and record it and share with all of the MRO companies in the world. It's very important because in aviation we say that regulations are written with blood. It's kind of scary, but it's necessary. All of regulation means all of rules is so important. You must obey all of them. Sometimes pilots complain about it. They don't like us very much because of them, but they know the means of the rules and regulations, so it's okay. Okay, I just wanted to say that about our work and what we do in Turkish Technics. It's the company of Turkish Airlines, but it serves all of the world, of course. As I said, if any of you want to work with planes or aviation systems, please let me know. Especially after the class, you can mail me, and maybe I can help you. Maybe some interview or scholar. Okay, the engine service. Maybe you can interested with engines because in the class I think there is not only the electronic engineers. There's also mechanic and mechatronic engineers in here. So our number is very good. Okay, I will share you my mail, and you will see it in presentation also. When we started lesson, I will share with you a presentation. We will go on there, and there is my name, mail address in there also. But I can write here for you. Okay. Now you got my mail address. And there is also in NDT service, NDT means non-destructive testing. You are testing the components, but without not harming them. It's very important systems. Engine service, maybe APU. APU is also very important for big planes. It's the backup engine, kind of backup engine. Maybe landing gear service is so important. All of you must be here about landing gear service because most of plane crash causes because of them. The landing gear service is so important. Component service also. If you work with MRO company, you have to check all of the components, and you have to make it a pool component. We say that component pools, and you must share your component pools with all of MRO companies, all over the world. In the world, is so important. They have to help each other to stop the plane crash. Also, engineering service. You can research the MRO companies. For example, Lufthansa, it's the biggest one in Germany. Our company is also the big one. You can work for research departments. I'm also working in research and development departments. We design the IFE systems, in-flight entertainment, or some healthcare system. Also, we repair the business jets and training service. Maybe you can access our training systems, and you can learn a lot about the aviation systems. Okay, Let's try to upload our presentation and begin the lesson, begin the lecture. Okay. It takes some minutes to upload it. Our number is good. Also, we have a lot of foreign students. We can stop it and share the presentation. Nope, it's PDF again. What about now? You can see the PowerPoint, I guess. Now. That's good. Okay. This course is on digital circuits. Actually, it's logic circuits and digital systems. And you can also write my Gmail, but I already give you. So we will see in this lecture digital systems, binary numbers, conversion, signed numbers, signed and unsigned numbers, complements of numbers, and binary codes. It's the basis of the digital system. It's a logic circuits. Okay, as I said, this course is on the digital circuits and digital systems, logic circuits and digital systems. We have signals, right? We say a lot of signals. We will say a lot of signals. Actually, what is the signal? How can you describe a signal? Because you will heard a lot all of your university life. Also, you will say a lot signal because all you can do is signal processing for electronic engineer. It's the same as mechanical engineer. You get signals from the motors or some machines. A signal is a variation of physical parameter. For example, temperature variation is a signal. Speech, I am speaking with you. Speak now is also a signal. Video is a signal. And everything from the nature also it's a signal, I guess. And you do a lot of processing of the signal in real life because you have to use it. You have to transport it. Maybe you have to store it. For example, maybe, for example, if you take a microphone to speech, as I know, signal that you give into microphone, and then if you necessary, it needs amplified, for example, some filter. And give the signal to speaker, the sound signal, right? And the sound signal out of the speaker. So you do the signal processing. It's a typical signal processing scenario in microphone until the speaker. We are in electric engineering domain in this lecture, so we will talk about only electrical signals. That means variation of electrical quantity, a voltage or current, as a function of time. And as you see, there is an analog system and digital system. Is there any? Yes, a wave has length and dimensions also. Good. Analog system, the physical quantities of signal may vary continuously over the specified range. This continuously means a lot. It's very important. You will use it. In digital system, the physical quantities or signals can assume only discrete values. So, if we have to proceed any signals, we must use the discrete values. We cannot proceed the continuous signal. You can use any time for example, nanoseconds, microseconds, for example, hour. It's on you. You can use all of them, but you need discrete values. And with digital system, you get greater accuracy. So, a signal is defined as a variation of electric quantity, usually a voltage or current with time. Time is important in there. Of course, you can also have a signal which doesn't change with time. Then it's not called a signal anymore, right? You can say it's DC value. Maybe you will learn about it before. There is an AC, analog current, and there is a DC value, direct current. If your signal is not changed with the time, you cannot describe is just a signal. It's not clear. You can see it's DC value because it's not changing. It's not necessarily the process of the DC value. For example, if you know that the value is not going to change, there is no need to processing. So you know the value is, you can use the value wherever you want. It's not change with time. You can use it wherever, whatever you want. Normally, a signal can take any value, of course, within gives limits at different instance of time. A signal varies continuously. That's a signal. That's actually that's an analog signal. For example, you have a time variation of signal voltage level. For example, a signal as a function of time. As you can see it, if I plot this the signal, I can use the sine wave, for example, and this signal can take as a function of time. An analog signal, it is a signal which can take any value between two different limits as a function of time. I say it a lot as a function of time because it's important. So analog signal, this is a signal, can take any value between two different limits. But even though the signal varies, I am only interested looking at the specific intervals of time. Such a signal is a subset of the analog signal that is called a discrete time signal. As you see, we are transfer the digital system. We take the analog signal, but we can use it for a processing, and we make it the digital one with discrete. Even it's a 1 microsecond, then what happens between 1 microsecond, even maybe 1 nanosecond, can change in between this, and you will get this change, but it must be discrete. You must say it is that value in this time, so 1 nanosecond later it is that value, for example. Okay, let's see differences between analog and digital signals. I will share the presentation. If you don't read now, don't worry, you will get it. But I think it's clear. It can be You can read this. An analog signal is a continuous signal that represents a physical measurement. For example, earthquake, frequency, volcano, all of them, wind, speed, weight, all of them is analog signal. Digital signals are the separated signals which are generated using digital modulation. Analog signal donated by sine waves. It's important. You can get all of the analog signal by using sine waves. Sine waves is also important. On the other hand, in digital signals, it's donated by square waves. Usually, it's only 1 and 0, and in binary system. And in this lecture, you will use binary system a lot. Temperature sensors, FM radio signals, photocells, light sensors, all of them is analog signals. And analog signals make you represent the information with continuous range. You can use it the continuous range of the values that can help you to represent information. But as I say, it is so hard to process any analog signal. So you have to discrete it and you have make it a digital system. So you can do any signal processing. Analog signal bandwidth is low. The digital signal bandwidth is high. It is important because when you see the electronic circuits, maybe you will make a components for any devices, and you have to say that I create this component, I create this electronic circuits, but it's only working on this bandwidth. So it is important, and yes, it is possible, and we will see the after this presentation, you will see that there is not only digital or not only analog system in the complex, especially in the complex system. You have to use both of them. You get the analog signal, and you will use the analog digital converter, and you process the signal. Then you will use the digital analog converter. Then you can use it. There is also not meaning to give somebody the digital signals. You have to make it analog either. We will see that. So bandwidth is important, so important if you want to, maybe you will work in military system and you will see a lot in bandwidth. What is the bandwidth? Why is so important? You will see that. Analog signals are determined by noise. Maybe you can eliminate the noises with filters, but they say there is a noise. Also, analog hardware never offers flexibility implementation. Digital hardware offers flexibility in implementation. Also, it is suited for audio and video transmission. As I say, you cannot send the digital signal to people or speaker or something. It is meaningless. It's only 1010. You have to change it to analog. Then people can understand what you say or what the circuit means. It is suited for computing and digital electronics for digital system. And analog system processing can be done in real time and consumes laser bandwidth compared to digital system. It never gives in digital systems, it never gives a guarantee that digital signals processing can perform it in real time. So analog signal doesn't offer any fixed range. Digital system has finite number, 0, but in analog system, everything is infinite. You cannot say it will be done this value or it's okay. It's not up to you. Analog system can change every time. So, as you see, is it possible to convert analog signals to digital signals? Of course, it is necessary also. You cannot do anything without using them. You have to use them a lot. For example, the microphone examples I said before. You give the microphone sound, right? It means it's analog. I'm speaking to the microphone. It is just sound, analog signal. Not too good. You cannot process the sound or analog any signal. You have to use analog digital converter. ADC. You will hear a lot all of your university life. Also, you will use a lot. Whenever you want to make a circuit, most probably you have to use ADC or DAC, analog digital converter or digital analog converter. So we take the sound, we use analog digital converter, and we make it digital signals, and we use some signal processing, maybe amplified, maybe sound needs amplify, maybe filter. We use the filter to more clear sounds, make a more clear sound. Then you also have the digital system after the signal processing, right? You have 1 0 1 1 0. If you give them directly speakers, it means nothing. Imagine that you say the people 1 0 1 0, it means nothing to people. You have to convert the digital system, the analog sound, and you use the digital analog converter. Then you have much better analog signal, and speakers do the rest. Okay. There is two types of digital signals: combinational and sequential. It's a basic differences between combinational and sequential logic. Combinational logic is a type of digital logic which is implemented by Boolean circuits. Also, we will learn the Boolean algebra, where the output is pure function of the present input only. This is in contrast to sequential logic, in which the output depends on not only the present input, but also on the history of the input. So, what does that mean? That means sequential logic has a memory. Combinational logic, it's not. I am saying it again. Combinational system has no memory. You cannot store any of information in combinational systems. But in sequential systems, there is a memory. You can use it. You must. Not you can, you must use it for the out of function. In the previous lecture, you will learn about it. We do a lot of examples. Don't worry. Maybe it's not clear for you now, but it will be. You must now know now its combinational system has no memory, hasn't a memory. Sequential system has a memory. It's important. So all of digital system is output is function of time. Yeah, that's right. In these cases, you can only say that combinational system. I cannot use the previous data, previous time of function. You can only use the in that time. But in sequential system, you have memory, and it depends on previous input also. In combinational, there is no previous input, but in sequential, there is a previous input also. So, binary system. It's the most important thing in the logic circuits. Someone clever said that there are only 10 types of people in the world: those who understand binary and those who don't. It's a joke, right? It's obvious joke because they say 10 types of people, but it separates them is two parts. I hope after this lecture you will get the joke and you will learn the binary system. It's my hope. Maybe you heard about binary system before. I don't know that. Okay, binary system means 1 and 0. Only have two values, 1 or 0. An information variable presented by physical quantity. It's for binary digital system. For digital system, the variable takes on discrete values. We said that a lot. Two-level or binary values are the most prevalent values. There is another type of digital system, for example, fuzzy logic or something, but we will not learn in this lecture them. We only work with binary system now. Binary values are represented abstractly by digit 1 and 0, of course. You can say them and you will face with them sometimes in the circuits they write false and true. So that means if you take a digital circuit and you will use it maybe, and in it's writes false and true. You should know that false means 0, true means 1. Also low and high, also you can see that. And on and off. It means 1 and 0. Binary values are represented by values or range of physical quantities, as you see. So let's see the decimal number before seeing the binary, because all of you know the decimal, because in your real life you're using them. It's also said base 10 numbers. Actually, in binary system, we use the same rules as the decimal number. So we will see that. Now, before we learn about the binary system, we look more details about the decimal numbering system. I am trust on you all of guys now the decimal numbers. The principles are the same for the all number system. With the binary, we will use also hexadecimal, octal, the other number system we will learn in this course. And as I say, it's the decimal system based on 10 and numbers range 0 to 9, right? Digital position, integer and fraction. Digital weights is base position is power of 10, and magnitude, digit and weight, as you know, the formal notation. You can see that 512. You use in there the 10 power of 0, 10 power of 1, and 10 power of 2 to describe this number. Also 10 power of minus 1, 10 power of minus 2. You know all of this calculation for decimal numbers. So I want to learn binary then octave maybe. In binary system, the rules are the same, but only the numbers range is 0 to 1. There is only two numbers, 0 and 1. We call them bits. It comes from binary digits, and we will learn bytes, megabytes, gigabytes. We will learn them. As I said, we call them the bits, 0 and 1. Weights is the same. It's 2 power of 0, the first one, and 2 power of 1 to power of 2, and continue with like that. So just look this number 101 point. There's a invisible point in there, 0 and 1. We use to describe the numbers with using the power of 2. We start with right and go the left. We will see most important bits and least important bits. We will see that. So it is kind of the conversion. I think we took the binary numbers. We can say them digits. We took the digits and we make it the decimal with using the power of 2. Okay, let's see the octal numbers. Octal numbers base 8. It's important. If you want to go with software engineer, or maybe you want to be a computer engineering, like software engineering, you want to make a code, write a code in your work life, you have to learn them very good, because you will face with octal numbers, hexadecimal numbers, binary numbers. You always think about them when you write a code, when you write a software or something. Okay, the octal numbers based on 8, and we also will set them the byte. If it's 1 digit, we say bit, and there's a 8 digits, we say it's byte. And the rules are the same. We use the 8 power of 0, 8 power of 2, 1, and 8 power of 2. After the point, we use the 8 power of minus 1 and 8 power of minus 2, and continue with that. Continue like that. So there is a hexadecimal number. If we use the laboratory in this courses, I hope you we will use SIC FPGA, filed programmable gate array. And when you start to write a code, it's not software, by the way. Don't mix. It's hardware coding. It's named VHDL. Hardware description language. Maybe you can learn in this courses. I want that a lot. If we can use the FPGA in laboratory, you will use a lot of the hexadecimal numbers when you code something. You will see that. I give you a problem. Okay, Mustafa.
Hello, teacher. I just don't understand the one in yellow. Like, what's this number?
What is the?
Yeah, what does it mean?
What does it mean? Hexadecimal number or the other ones?
The numbers in yellow.
Yellow numbers. Okay.
Yeah, 1E57A.
1E5. Okay.
Yeah.
We said in the decimal number, it is base range from the 0 to 9, right? In decimal number. Also, in the octal number, the range is 0 to 7. It's also okay. You know the numbers. 0 to 10. In binary, there is also 2, 0 and 1. But in the hexadecimal number system, the range is 0 to 16. So we know the decimal 0 to 9. We know that number. But after the 9, we cannot use 10, 1 and 0. We must use different description. And in the hexadecimal system, they use A, B, C, D, E, F. A means 10, B means 11, C means Okay. Yes. Siemens 12, 13, 14, and 15. As you can see, we cannot use 10 to describe 1 and 0, right? Because that means the difference. That means 0, 1, and we cannot use the, for example, 11, 1, and 1. Because there is a hexadecimal numbers, and the range is 0 to 15. We must use 16 description symbols. Let's say that the symbols, not numbers. We use the 0 to 10, it's number you know, and A, B, C, D, E, F. And we can write with that. So, write E means the 14, F means the 15. And there's a 16 number. Because we start with 0. We start like a decimal system. You say why we use this like a 16. In decimal system, we say it is 10, right? In the decimal system, the range is 10, base 10. But it's started with 0 until the 9. It's the same with hexadecimal system. It started with 0 until the 15. I didn't know what you want to say. So I got the 9 is start from 0. I don't get your question. In the yellow number, we say 1, E, 5. We cannot say it's mean 100 E5. We should write it the digit as a digit. We can say it 1 E and write. We will see the conversion. Don't worry. We will see the how can we conversion the hexadecimal to decimal or binary to decimal. Actually, we write them, but we will see the more clear because the same as the decimal. Yes, E is from E just mean is 15. And no, E means 14, F means 15. Okay, let's continue the other. And there is a like a state machine system. Yes, we start from the 0 until the range. If we decimal number, it's until the 9. If hexadecimal number, it's until the 15. Okay, you can examine this system. It's the octal base 8, decimal base 10, binary base 2, hexadecimal base 16. Okay. Let's start with the conversion. The power of 2, as you all of know, the power of 0 we use, and when we get the power of 3, 2 power of 3, we get the byte. In 2 power of 0, we get the bit. In 2 power of 10, we get kilobytes, megabytes, gigabyte, and terabyte. You will see them. The binary number system is also called the base 2 number system. Is a method of the representing numbers by using combination of only 2 numbers, 0 and 1. We say that. Computers use the binary number system to manipulate and store all of their data, including numbers, words, video, graphics, and music. As I said, if you want to process some signal, we have to make it digital. In the computer systems, we have to make it binary digital. We have to make it 1 and zeros. So we can use it, we can store it, we can process it whatever you want. There is also a fuzzy logic, but I don't want to confuse your mind. You will learn it maybe after the class. Okay, binary numbers. Binary to decimal, you see that. Decimal system, units, tens, and hundreds, as you know. In the binary system, the rules is same as I said, because it is the 10 power of 0, 10 power of 1, 10 power of 2. Guys, we have the 5 minutes break. I'm sorry to take the door. I'm coming. Okay, I'm sorry for break. Maybe we can take the 5 minutes. I have to take the door. Okay, I will say the book numbers. Thank you for reminder me. I forget them. Okay. I'm sharing the book numbers. You can get the PDF, I think, from the internet. I don't know. I didn't look at them. But I think you guys figure out. You're welcome. I don't have the PDF right now, but I think in the internet you can find it. Maybe it is not legal to I share the PDF. I don't know. I will look at and I will announce you. Don't worry. But in my advice, try to write the Google and I think you will find the PDF because they are not the new. So it's okay. I can, if I, whenever I want, I get the PDF, I will share with you. I guess until next week, I will be shared. No problem. As I say, if you have questions about the lecture, about the lessons, you can mail me, and maybe it will be very efficiency. I think I uploaded. Maybe there was a mistake. I will check, and if you cannot get the slides, I will fix it, and you can download the slides. Don't worry, I will handle it. Okay, let's continue. There is a decimal system and there is a binary system. You see that the convert them. We saw that the decimal numbers, the weight of each digit from the right to left increases by factor of 10, right? In binary system, it's the factor of 2. In the binary number system, the weight of each digit increases by a factor of 2, as you see. Then the first digit has weight 1 plus 2 power of 0. Another one is 0 plus 2 power of 1. Another one is 1 plus 2 power of 2. And you make the conversion. It's the easy one, the binary to decimal. And you can see that much more clear in the slides. Also, as I said before, two important definitions in the binary system. There is a least significant bits, it means LSB, and there is a most significant bit, it's a MSB. You will use a lot these two description. The least significant bit is the right part of the number, digit number. The most significant bit is the left. Please don't mix them, especially in the exam. The right digit, the least significant bit, and the left one is the most significant bit. Please keep it your mind. So, binary numbers, name and prefix. As we said, the one digit is bit 2 nibble. You see the nibble if you want to have software engineering, and if you want to write some code, you will use the nibble. And byte, the 8 digit, word, double word, quad word. This actually not the type of this lecture. It's kind of software program languages. If you see the lessons, I just want to know what does that mean. So the nibble means 4 bits number. Word means 16 bits number. It is not. It's just out of scope for us. But I just want to know the description. Okay. And there's another example to binary decimal conversion. I think you understand this one. So, decimal to binary conversion. What does that mean? How can we get the decimal number and make it the binary one? We use divide operation. Dividing each decimal number by 2, as you can see from the figure. So, if you see that, we'll give a result plus a reminder. For example, when you divide 266 to divide it's 2, and you get results. What is the results? 133, and also you get reminder, right? If the decimal number being divided is even, then the result will be whole and the remainder will be actual, right? Remainder will be 0 if the number is even. If the decimal number is odd, then the results will not divide completely. The remainder will be 1. It's basic divide. You just divide the 2. And keep it. Keep continue to dividing until the 0 or until the 1. Because you cannot divide the 1, 0, to 2 parts. As you see, we have a number 266 and we want it to represent it by using binary system. So it means, what is the means to 266 in binary system? How can we write it? We start the divide, it's 2, and keep the remainder. We always keeping the remainder, not the results. It's meaningless, right? We cannot use the 133 or we cannot use the 66. We only can use 0 and 1. So we are using the remind part. The binary result is obtained by placing all the reminders in order with the least significant bits being at the top and the most significant bits being at the bottom. What is the least significant bit? This is the top one, right? In this example, it means 0. And there is also most significant bits. It is the last reminder. Last results, pardon. The last one is results. The others was reminder. Okay. Let's see some example about digital binary conversion. We said that it divides the numbers by the base of 2. Take the remainder. It is either 0 or 1. And take the results. The last one is the results. So there's an example. We want to use 13 with binary system. We divide 2, we get 6, remainder is 1, and coefficient is 1. And we keep it continue. 6 divide 2, and the results 3 and remainder 0. And the other one is results is 1, remainder 1. The last one we only use this remainder, and we get the answer. My advice, do a lot of example about that. You can get a lot of example from the internet or from the book, and you will use it. And there is also decimal to binary conversion too, but there's a difference between this one and this one, because this one we have a fraction part, right? So in this part we use divide, right, to convert the binary. What about the right of the points? This one we use the multiply. Multiply the number by the base 2. If the numbers has fraction part, not only the integer, but we have the fraction part, we use the multiply for the fraction parts. For example, okay, let's see that. Take the integer 8, either 0 or 1 as a coefficients. Take the results fraction and repeat the divisions. Example. Let's see the example. It is the easy way to learn something. So we have 0.625. What will we do? We use the multiply, right? Okay, sorabilirsin.
Hocam merhaba öncelikle de. Hocam ben buradaki bahsedilen sayıların ne olduğunu tam olarak anlamadım.
Şimdi bir tam sayılar var. Bir de fraction part dediğimiz hani bu virgülden sonraki sayılar var. Integer dediğimiz tam sayı, fraction dediğimiz virgülden sonraki sayılar.
Bu
Roundabout sayı.
625 dediğimiz herhangi bir sayı değil mi? Yani örnek olarak verilmiş bir şey.
0.625 yani birden daha küçük.
Tamam ama örnek yani herhangi bir şey değil.
Evet herhangi bir sayı.
Tamam, teşekkür ederim.
All of the numbers you see in lecture is just an example. We can use the different numbers also. So 0.625 we minus 2. We got 1025, right? If you do this calculation, please do it if you have pencil and some paper. Please do the calculation. Just this number plus 2. You will get that. 1 minus 25. And for the binary system, you will use the integer part. This number is less than 1, right? It's between 1 and 0. It's a very little number. And if you plus it with 2, you will get that number and you will get also integer part. And always use the integer part as a binary. And we are getting the integer part is coefficient. And we will use the fraction part again. We will use the 0.25 minus 2. And also we get the 0.5. There is no integer part, right? So it means 0. So use it fraction part again. 0.5 plus 2 and you have 1. So you get the answer. Answer is 0.101 in the binary system. I hope you can understand it, but you have to do a lot of example about that. So you can understand very well. Otherwise, it can be confused for you. So let's look at again. For the integer numbers, it means in Turkish tam sayı, as I said, in the integer numbers, we use the divide for the decimal to binary conversion. In the fraction numbers, that means after the point, that means less than 1 numbers. In here, how is 6 equals 1 and 3 equals 0? I don't see the 0 in that, but let's do the calculation again. The last one. Last one is 0.5. We multiply it and we get 1.0. Okay. This one. Okay. We have 13 and we want to make it the binary number. We divide the 13 the 2. Result is 6 and remainder is 1. So we got the results and divide it again. We got the 3 and remainder is 0. So we got the results again, divide it. 3 divide 2 and result is 1, remainder is 1. Then we got this one, but this one is not necessary. You can use the results as we see in that. We use the results, not reminder. Is it clear? Not the last one. Until the last one, we always took the reminder, but the last one, we can use the results. And result is 1. This one, because we cannot divide the 1, right? Yes. When we use the odd number, the remainder always will be 1. When we use the even number, the remainder always will be 0. Okay. As I said, you have to do a lot of examples about that. Yes, we can say that. As I said, there is a odd number. If there is an odd number, the remainder will be 1. And if there is a even number, remainder will be 0. Okay, please do this example with on your own. Get the pencil and get the paper and do this example maybe after the class. Yok, tam sayı değil, çiftse 0, tekse 1. Even ve odd. Even means çift sayı, odd means tek sayı. Okay, there is a binary, the octal conversation. This is also the same, but you have to do a lot of exam, as I said. In the octal conversation, there's a 8 bits, 8 digits. And the binary, we use the 3 digits for that to represent them. Okay, let's check the example. But I think we don't have time for this. We only have 3 minutes. Let's see what we have for the next. We will see octal hexadecimal conversion. Okay, Mohammed, you can talk.
Sir, I just want to ask a question. For this course, what is the main quest for this course? Are we going to understand how to build a physical circuit, or it's just binary systems and
Yes.
these systems?
We will learn both.
Both.
We will learn the binary numbers, and we will learn the gates also. But all of part is theoretical, because we will learn the Carnot diagram, truth table, state machines. All of them actually is the theoretical. But if we get the laboratory, we will make them in the circuits. We will use all of the gates.
Okay, thank you.
And you will see clearly, I hope.
Okay.
But I don't know now, because it's the university decisions.
Okay, thank you.
You're welcome. Okay, there is a hexadecimal conversion. And we will see the octal and hexadecimal. And we must see the signed binary numbers, unsigned binary numbers. Okay, we will see the next week. Also we have to do makeup course, because of the previous week we couldn't make the lessons. We will decide the date, and I will announce you. I don't know how, but don't worry, I will learn how to announce the students the date, and you will get the announce about that, and we will do the makeup lessons. We are 1 lessons behind because. Okay, our lessons is done for today. Okay, I will try to get PDF and I will share with you. This WhatsApp group is for this class. Can you hear me because my screen is frozen? Ah. Guys, can you hear me?